Welcome to NucleCast, the official podcast of the NWA Deterrence Center. Each week, we bring you leading experts for a lively discussion on topics related to strategic nuclear deterrence. Our host is Dr. Adam Lowther, Director of Strategic Programs at the National Strategic Research Institute. The views of the hosts and the guests are their own.
Welcome back to another exciting episode of NucleCast, where every episode is exciting because we always have great guests and great topics. Of course, I'm your host, as always, Adam Lowther, and today we have not just one, but two of the best weapons physicists in this great land of ours. Of course, you may already know them. Charlie Nakhleh and Mark Herrmann from Los Alamos and from Lawrence Livermore. Mark is the program director for weapons physics and design and weapons and complex integration. And of course, Charlie is the associate laboratory director for weapons physics at Los Alamos. And they both have big jobs, and they've spent, 2 decades, more than 2 decades for both of you on the weapons side and the physics side. So welcome into NucleCast.
Thanks, Adam. Great to be here.
Yeah, thank you so much. Really looking forward to it.
Yeah, so this is actually, it's great to have both of you. So we have the two main weapons physics labs represented here. And for me as an Air Force guy, most of my career, I've spent a great deal of time at Lawrence Livermore, and then having, run the School of Advanced Nuclear Deterrence Studies down at Kirtland, spent a lot of time up at Los Alamos, especially at Pajarito. And then after a day of skiing, you always go to Bathtub Row Brewing Company. How else could you end the day? So
Absolutely.
It's both great places to live and work. So with that, let's talk about the future. We have, we've got two peers, which is, it's something new. We've got a Russia that has the potential for breakout, with its suspension of New START, and then with its massive and varied low yield tactical nuclear weapons capabilities. And then with China developing a program that, we expect to be a peer of ours on the strategic side. And then, I see less on their specific low yield and tactical weapons. That's an area where I think there's some questions still. And so you guys are tasked with building the capabilities that help us to deter those adversaries, not to mention a North Korea that's building a much larger capability, both strategic and tactical. And then we've got an Iran that's on the verge of breakout. So as we look at all of the threats, sitting in your positions, what are you guys thinking? Sort of what's keeping you up at night? How are you processing these challenges? What are you thinking about doing to address those challenges and concerns?
That's a great intro, Adam, and a great set of questions. If you look at policy documents like the National Defense Strategy and the Nuclear Posture Review, that have been put out recently, they really emphasize, the points you've made about the challenges of the security environment we're facing, the changes in the security environment, the modernization and expansion of Chinese nuclear capabilities, Russian nuclear threats to the U.S. homeland, to allies, partners, and the whole spectrum, just as you pointed out, not to mention, now there's a major land war in Europe for the first time since World War II, right? So that's a very complex situation, and it's changed dramatically over the past 25 years, since the 30 years since the end of the Cold War. In response, right, the country does have a complex and significant modernization program that it's undertaking right now. We're trying to do a lot. I think you had General Stacey Huser on one of your podcasts, and she kind of laid out, the scope of the challenge and the work that we're undertaking as a country. So So that's a big effort, and we're trying to apply, the most modern research, technology, development, engineering, and so forth to that effort. We also have a big effort in terms of stewarding the stockpile we have, the existing stockpile. That's a big and important issue. That requires a ton of specific technological and physics and computational and experimental science expertise, material science expertise, and the like. But that's not all that's not the entire scope of the challenge, right? We have to be also ready ahead of evolving threats and be ready to meet them, right? We're not going to be able to predict necessarily everything that comes down the line. So we've got to have a stance that enables us to meet them effectively for the country, provide options for the country. But the foundation of all that is stockpile research, technology, engineering, and science, right? That's the work that we've been doing for the last more than 25 years as part of the stockpile stewardship program, and that's going to be the foundation of all of these efforts in terms of getting ready, executing the modernization program of record, getting ready for the future, stewarding the existing stockpile.
Yeah, I just add, I kind of look at this through a few lenses. One, right now we have an aging stockpile that is the foundation of our deterrent, and so every year we do a very careful and thorough study supporting the annual assessment of that stockpile, and that's getting more and more challenging as the stockpile ages. But it's critically important because that is the thing that is deterring our adversaries today. And so we can't ever lose focus on that, right? And then on top of it, now we're in the midst of 5 either new or modernization programs, life extension programs that we're having to reconstitute capabilities that we haven't really had in the post-Cold War era. And, we have to manufacture things in different ways. We have to use different materials. We have to meet different, evolving requirements like new delivery platforms or new challenges on the stockpile target sequence. And so that's driving us, our ST&E capabilities to, kind of meet that challenge while we have to maintain this aging stockpile. And while we're doing that, we've got the whole production complex that we didn't invest in for almost 30 years that we're trying to reconstitute. And again, we want to reconstitute that in a way that gives us the most flexibility for the future. So we're trying to use the most modern manufacturing techniques we can use, not just the techniques that we used when we were making the stockpile that we have today in the 1970s and 1980s. And so that's driving a need for our focus on ST&E and our ability to help inform those choices. And then we look at all that, and unfortunately, it just takes us too long to respond. Right now, our modernization programs take 12, 14 years to put something from beginning of the concept to put it into initial operating capability. And I think it's been widely recognized that is not going to, that pace will not deter our adversaries in the future, especially as they're innovating on a pretty rapid timescale. And so I think the whole complex is thinking about how do we go faster in the future, and a big part of that is do we have the ideas, do we have the concepts, are we ready to go should someone come and ask us and say, hey, we've got a gap in deterrence here, this is the capability we need. We have to be ready with the potential answers. And so we got a big part of what we're doing right now is thinking about those things so that we're ready to kind of be able to plug that gap and try and shorten that time so we can respond. So it's incredibly exciting time, an incredibly challenging time, and a lot riding on it.
So if you were to sort of rank order your greatest sort of challenges or needs, whether it's talent, whether it's the infrastructure, what would you sort of prioritize, and why would you prioritize? What are those, sort of challenges as you see them?
Yeah, I guess that's a good question, and it's a really hard question because there's really not one part of this where we can let let it drop, right? We can't take our eye off of that aging stockpile. We can't not deliver the current stockpile, and we have to be thinking about the current stockpile modernization programs. And we got to be thinking about the future. So an overarching need, I think, is a stable workforce, and a workforce that's gaining experience. That's as we've ramped up. We've done a lot of hiring. We've been able to hire great folks, right? Across the board at every one of the sites in the complex. The biggest demographic is the kind of the folks with 0 to 5 years of experience, right? Which is great that we've been able to get them into this important mission. My biggest worry is how do we keep them, right? Are we going to keep them here for long careers? That's been the history of this program, is we've been able to keep people for 20, 30, 40 years, some as much as 50 years in this, kind of, because they're so connected to the importance of what we're doing. And, we're a more dynamic world today. And so will we be able to keep them? How do we make sure that they, we give them the opportunities, the challenges, support them so that this is how they want to spend their careers, right? That's the thing I kind of all the things I worry about, that's the one I worry about the most right at the moment. So
yeah, I often get this question about, well, what's your priority? And to drive a car down the road, you can't do it on just one wheel. You can't say my wheel is my priority. My driver's side front wheel is the priority, right? You need all the wheels. You need an engine. You need a steering wheel, and so forth. And I think we're kind of in that situation. And so I totally agree with Mark's emphasis on workforce. That really is it. Ideas start in people's heads, right? And that's always the place that you start. And it takes a long time to learn this business. To make a weapons designer takes more than a few years worth of study, practice, experience, doing experiments, understanding how these systems work, and so forth. It's not a 1 year in and then you're productive, right? So it's a long-term investment in people.
Yeah, it's a good point, because I'm not sure if most people realize that, with the exception of maybe there's a program at the Naval Postgraduate School and a program at the Air Force Institute of Technology, your civilian academic programs are not training physicists and nuclear engineers to be weapons designers.
Right.
That's so you've got to take somebody who has a physics background, or oftentimes a reactor focused background, and turn them into weapons physicists and engineers, which, as you just said, it's not that fast of a. So do you think that is civilian academia producing sufficient numbers of quality candidates? And I asked this because I was talking to one of the nuclear engineering departments, the faculty, yesterday about their program. And it seems that there's a consolidation of programs into a fewer big departments, but it's also given that, American students, native born Americans, the kinds that can get a Q clearance, tend to want to be social influencers. And, like communications is the single most widely granted degree in universities today. And so therefore we've had a large influx. When I went to graduate school, all of my peers in the Ph.D. program were Chinese nationals, but they can't come work in the weapons complex. So is there a big enough pool of people that you can draw from as you're trying to go out and recruit these folks who are fresh out of school? Is there enough of them to sort of meet all your demand, all your needs?
I think the short answer is no. The good thing is American graduate schools and universities are the best in the world, right?
Sure. Yeah.
In fact, the best from around the world come to be educated in our graduate schools and get PhDs at our program. So that's a good thing. The bad thing is we don't have enough American citizens going into these fields. We just don't. into the STEM fields, and we need more. We need, I think, kind of personally, the national emphasis on that we had after Sputnik, right? Sputnik, generated a whole generation of American scientists and engineers, a couple of generations, that really powered us. And I think we do need more U.S. citizens going into STEM fields for graduate degrees. That would be a very good thing to have.
And are you guys, either one of the labs, doing much in terms of, because it's often people choose careers based on what they're influenced by, when they're young. Like, I've got a 12-year-old son, and my 12-year-old son, has seen me spend a career with the military. And, so he's already decided, I want to go be, a nuclear ET, and I want to run a reactor, on a ballistic missile submarine. And then I want to get out and I want to get a nuclear engineering degree. And he knows sort of what he wants to do. And he's just by observation and, things that he wants to be like his dad. And so I wonder, as we think about trying to influence that American generation, like the race to the moon and, that whole era built all of these great scientists. And then the Manhattan Project drew in a bunch of young folks. What are we doing today to try to inspire 12, 14, 15-year-olds nationally?
It's a great question. I do think we are, there is a lot of effort to do that outreach early, because I think you're exactly right that kind of you want to set the bit as early as you possibly can. And so we think about things like, we have a Science on Saturdays, which is kind of targeted towards elementary school people, talking about all the cool science going on at the laboratory. And then we, think about high school students and can we get internships for them? And then, college students and get them into the lab and have a summer here, right? And then that kind of can, and all of those things can kind of change the trajectory of someone. Just one good experience, right, can make a big difference in how people, choose to, pursue their careers. And so that's something we're very actively working on. I think the other thing is that there's a lot of untapped potential where, because of the history, right, we don't have as a diverse a workforce as we could, right? And that's basically talent sitting on the sidelines because, the messages have come down, if you're this type of person, you don't do science or you don't do engineering or you don't do that. And so we're also trying to really broaden that aperture and be much more aggressive in reaching out and kind of showing that, that everyone can do this work and it's really a fulfilling career and things like that. So I think there are efforts in that regard, but I think we still have it takes a long time from the beginning of the pipeline for them to get out of the pipeline and solve our workforce needs. So.
That's right. And you can't start too young, in my opinion. And one way you start is by making science cool. There's almost nothing cooler than science. It is a blast, right? So you look at last year, it was an amazing year for big science in the United States of America, right? Two huge things happened last year. One was the James Webb Telescope, right? What an amazing achievement. There's nobody else who's putting out a big telescope out at a Lagrange point. I mean, the first time I've had people ask me, what the heck is a Lagrange point in my entire life, right? And then the second thing was ignition on the National Ignition Facility at Mark's Place at Lawrence Livermore National Lab. That was an amazing decadal achievement, right? And so those things are cool, and those things are going to attract the interest. I can tell you they're going to attract the interest of young people of all ages and all backgrounds, and we should be proud of those and celebrate those and put those out as things that, hey, we want you guys to get involved, and doesn't this look interesting, right? I think they have a strong attractive power.
Now we're at that time of the show where we have to take a quick break, and when we get back, I want to shift topics and talk about science-based stockpile stewardship. So listeners, hold over from our quick commercial break and we'll be right back. This episode of NucleCast is brought to you by the ANWA Deterrent Center. whose mission is to educate Americans about the nuclear enterprise and strategic deterrence. And we're back. Of course, I'm Adam Lowther, and we're talking to Charlie Nakhleh and Mark Herrmann, and we're about to shift. If you've been listening to the first part of the show, we're shifting to science-based stockpile stewardship. Now, let me play devil's advocate. And of course, there are many who would say, well, we haven't tested in over, it's been 3 decades, and we've got all this new technology, and we can't quite know for sure whether it works or, being in a weapon over time, what happens to these parts. And so therefore we just need to test because that's the only way we can know. All of the modeling that you do with high performance computing is great and useful, but there's only one way to know for sure. So how would you guys respond to, these and other sort of typical challenges to our current approach to making sure our weapons work?
Let me start by just telling you the basic approach as to how we address any problem. And this was true during the testing era and has been true in the post-testing era for the last 30 years. There's basically only 3 tools available to do science: theory, experiment, and simulation of all types, right? Those are the basic tools that we have. And I split up theory and simulation only because for modern understanding of theoretical physics is always instantiated in terms of computation and computational simulation. And I think that's enough to merit a separate pillar. What's happened in stockpile stewardship over the past 25 to 30 years has been not that we've thrown away the nuclear test data that we have, not by any stretch. We have a tremendous archive of invaluable, irreplaceable nuclear test data that forms a strong foundation of our experimental knowledge, right, going forward. But we've tried to shift the balance away from having to get new nuclear test data, away towards better computation and more resolved and refined experimentation above ground at big facilities, places like NIF and like DART, and then upcoming there's the enhanced capabilities for subcritical experiments in Nevada and so forth. So that's been the balance that stockpile stewardship has achieved successfully for the last 30 years. So we also conduct a very strong surveillance program of the stockpile. As Mark alluded to, every year as part of our annual assessment process, we have surveillance programs where we're looking at seeing what's happening in the stockpile. We're doing experiments on that. We're developing models, theories, simulations, and so on to model it. And so for the past 30 years, that has been successful in maintaining the certification of all of the weapons in our stockpile. That is also going to be successful for all of the modernization programs that we have underway. And so when it's certainly true, and I've never denied that nuclear testing gave tremendous invaluable information. It did. There's no question about that. But the ability to shift while maintaining that test database and adding to it more and more detailed experimental information and computation that was literally inconceivable during the testing era, right? That's the new balance. That's the way in which we've maintained the stockpile and are conducting our modernization work.
Yeah, I just add that, again, the advances in the stewardship era have been unbelievable. The computing capability, when we get to exascale computers, when I started, we were we were racing towards terascale computers, right? So that's a factor of 1,000,000 increase in our capability to simulate what's going on. And then add in our ability to actually do experiments and take apart the problems that we never were able to do while we were doing testing, right? And I think another important thing to keep in mind is when we were testing, it wasn't like we were, it was rare that we were actually taking, things from the stockpile, putting them underground and doing a test. Most of the stockpile was developed without that capability and without specific tests, just for everything that in the stockpile, right? And so we were always having to extrapolate in terms of our understanding of the weapon, how it would work on the stockpile, the target sequence, what it might encounter, all those things. So we've always had that foundation of computation, experimentation, extrapolation based on, again, that over 1,000 tests. And then as we've gotten better and better computer capabilities, better and better experimental capabilities, we've been able to maintain confidence. And that's something we take incredibly seriously. Each year, that letter signed out by our lab director saying that the stockpile is, safe, secure, and effective and reliable is something we spend a lot of time working on, and lots of eyes go on that to make sure we're in that place. And so I feel, strongly that we're in as good a place today as we were at the end of testing, and in fact we've learned more since then, and feel like we're in a better place today.
So the experimentation that you are doing, it's much more granular, and it's you're answering very specific slivers of a question that are sort of filling in these seams and gaps that you had. One of the questions that I've wondered, and perhaps you can answer it, is the effects on new components that as you know, we don't build new warheads, we modernize warheads. But as you put in replace components, and maybe that, it's because so much of our industrial base that built these original weapons is gone. So therefore, we're not putting exactly the same components in. They're new components, and maybe they're made with new materials. They're structured differently. How do we exactly know the effects on those components as they're, a part of a warhead, that there's things going on inside that warhead over those, over the periods? What kind of testing or experimentation or simulation do we do to get at those kinds of questions?
That's a great question. And I think, from the very beginning of stewardship, it was recognized that we needed experimental access to the regimes that are important for our weapons and over which they operate, right? And so that led to, investments in capabilities like DART at Los Alamos, where we can actually put components in, subject them to high explosives, and see how they deform and implode, right? And then take a snapshot of what that looks like at the critically important time. So we do a lot of, for instance, explosive hydrodynamic testing to support our modernization programs when we have to change out materials or change out components, right? And then in the high energy density regime, when, after the explosives operates, then things, they get really hot and they get to really, really high pressures, right? And so we have 3 different experimental facilities: the National Mission Facility Charlie mentioned here at Livermore, the world's most energetic laser; the Z Pulse Power Facility at Sandia, which is the world's largest pulse power facility, uses electrical currents to create extreme conditions; and the Omega laser at the University of Rochester. And so we use those to kind of create as close as we can to the conditions in our operating weapons, so that we can study how a different material might behave at those extreme conditions, or how complex geometries might evolve and things like that. And so, again, we use that then together with this super advance in computational capabilities, and other major testing of, how the weapon's going to survive, and if it's shaped, rattled, or rolled, if it's under a lot of G forces, if it's has a hostile encounter. So there's just an entire suite of experimental capabilities backed by simulations that we use whenever we have to change out or even keep in an aging component, right? So,
Charlie, did you want to add to that?
I would just say, I mean, Mark gave a great summary of the approach, and I would only add that when you're considering, think of yourself considering a system ahead of you, and you try to shift the risk on that system to areas you can test, right? And put the risk away from areas that are harder to test, right? And you build in lots of margin and safety factors as well, right? So there's a judgment call in all of that. Um, and then you basically try to stack the deck as much as possible, right, in order to enable you to make the maximum benefit of the computational experimental tools that you have at your disposal.
Now we're almost out of time, so I want to give you guys a chance. If hypothetically, I were to give you each your magic lamp that you could rub to make 3 wishes, what would those 3 wishes be for each of you and your labs and what you're trying, to accomplish? Given, the world we live in now, what would you wish for? Mark, you want?
That's a very interesting question. So I would say I would come back to the workforce. I would wish for a much more dedicated focus in this country on the STEM fields from kids in grade school, right, and beyond, and all the way through, right? That would be at least one wish I would have, because I do think that is the foundation of the nation's competitive strengths in our field and in all others. And I do worry that we just don't have enough people going into science, engineering, and mathematics. So that's at least one wish I would make.
What would be your first wish, Mark?
I think it would be, how do we how can we go faster? How do we change? So, you look at the time it took to put the stockpile we have today into the stockpile, and it took on average something like 6 years, right? And I mentioned earlier, it takes us now 12 to 14 years, right? And that's even though we know more and we have better tools and we have, and what I see has evolved is this kind of risk avoidance, right? Risk, a fear, a failure, fear to take risks, and it's kind of it's so insidious because it's like it comes in everywhere, right? So, but to me, that's the biggest thing that's changed, right? At that time, they were putting things in the stockpile, and if they put something in and had to take it out, they did that, right? And that they were, we had, essentially existential threats that were driving that our tempo at that time, right? And so somehow, what I would wish for is an ability to kind of, not take careless risks, but get back to that place where we can respond on the time scale that's required. And that, unfortunately, I think a wish is, a wish may be needed, because right now it feels like, there's just
Yeah.
even though we've had many commissions and many studies and all that things, right? It just, we can't overcome that challenge right at the moment. People are working on it really hard because we know it's critically important, but it is the thing that I wish for. So.
How about you, Charlie? Wish number 2.
Oh, wish number 2. Well, yeah, I'm certainly with Mark on that wish. There's no law of physics or even economics that I think says we have to spend all of the time that we do. So on a lot of these issues. I guess wish number 2 is I wish that we would do, this is going to sound a little odd, but wish we would do more things in the real world and fewer things in the digital world, if that makes any sense, right? We need a much greater pace of experimentation, for example, on the facilities that we do have, and getting the new experimental facility capabilities up and running. We just need, again, we need to go faster. We need to get Mother Nature's vote on things much more quickly than we do, and get that kind of feedback loop going. Because that's what, the great people we have coming into our program, they really want to get out and do stuff, right? And so they really want to get that experiment done. They want to get that data. They want to get that feedback, and start to grapple with Mother Nature. And so I think, enabling them to do that is one of the key tasks on my plate, and I think on Mark's plate as well, right? In terms of giving our people that opportunity.
And wasn't that how, if you go back to the early days of
Yeah,
physics, you had a theoretical physicist, he has an idea, she has an idea, then they turn it over to an experimenter, they build the experiment, and they test, and then we see, is it true or not? And so,
exactly.
yeah. How about you, Mark? Wish number 2.
Yeah, so I don't know if I get to count Charlie's wishes as well. I mean, do we get 6 wishes or 3? Because all the things he mentioned are things that I would wish for. I would definitely on the workforce. I completely agree that because again, the competition. We see the effects, right? The effect is, adversary capabilities that are, being put in the field much faster and even surprising us, right? The underlying thing that enables that is advances in their science, technology, and engineering capabilities. That's that foundation that they're building on, right? So the ultimate long-term competition is really a science, technology, and engineering competition. And the key to that is workforce. And I think it is, we talked about, of course, people born in the U.S. who are critically important, but we, of course, have a legacy of from the very beginning of the Manhattan Project, benefiting tremendously from people coming to the country and becoming citizens and helping keep our nation great. So I think both of those things, kind of, and that then also points to the importance of our allies, right? Because it's going to take of all. We alone, the U.S. can't do this alone, right? We need that workforce across not just us, but our allies, those strong partnerships, and again, in that ST&E area, critically important. So.
How about a third, Charlie, a third wish? Because you only get 3.
All right. My third wish is that we spend a little more time than we do now on focusing on great things, doing big, great things, right? Again, I refer to things like James Webb and ignition on NIF and so on. Those were great things. And they're risky things. You're not sure you can do them, right? And you have to work really hard to make them happen. And those were things like when Kennedy said, I'm going to put a man on the moon by the end of the decade, right? That sort of thing. Those are the things I think that built this country, right? That inspired so many people from around the world to come here. And I know that very deeply, on a very deep level, from my own experience, my own family. And that's what's going to drive the innovation that the country is going to depend on as we move forward in the future.
Mark, your final wish?
Yeah, I'm sorry, this is going to sound Pollyanna-ish, and I don't want it to, but obviously, it would be even better to live in a world where we can avoid these conflicts. We can find a path, successfully to a stable world, a world order that is, a free, fair, open, democratic world that actually, so that the long-term, landscape is such that the things that are driving our adversaries are, underlying, a desire to kind of control their populations, to kind of set a world order that is not like the world order that we're advocating for, right? So, if we could get to a world where those things actually cost them, and they can't maintain that kind of control, and our way of life is recognized, kind of the freedom, democracy. That would be, maybe that would put me out of a job, but it would be better to be in a world that that was like that, right? Until we get there, we obviously have to make sure we're doing all the stuff we're doing. But I would be happy to be put out of a job if that's what it meant. So.
Charlie Nakhleh, Associate Laboratory Director for Weapons Physics at Los Alamos, and Mark Herrmann, Program Director, Weapons Physics and Design Weapons and Complex Integration. Thank you both for joining us on NucleCast.
Thanks, Adam. It was a real pleasure.
Yeah, it was a lot of fun. Thank you.
And thanks to you, the listeners, and we will see you on the next episode of NucleCast. Well, afterthoughts. That was a great discussion with guys who lead the weapons physics programs at the two main design labs. Now, it's always you have to be careful about, getting in too much detail about specific programs because of classification. So therefore, we had a great discussion about what is going on at that, 30,000 foot level in the labs and in the programs, and in, a discussion about stockpile stewardship. And I thought Charlie made a really sort of an interesting point, particularly for non-lab folks, about, hey, there's three things we're going to do: theory, experiments, and simulation. And then if you put things in those contexts, then it makes a lot of sense to sort of why we do what we do. And you can put testing, or you can put, the science-based stockpile stewardship, all of that in that context, and make it work and fit. So that was really interesting and good. And then just to hear, similar lab perspectives, because, the labs have competed, over the last 5 decades. And so it's interesting to hear one lab versus the other. And they really seem to be, sort of we're all on a similar page, all going to have different cultures and different approaches. But it was really interesting to see how both Mark and Charlie saw things and what their big issues were. So that was great.
This has been a production of the ANWA Deterrent Center. Our executive producer is Kimberly Charrington, and this episode has been engineered and mixed by David Krumthal. Follow the show on LinkedIn, Facebook, and Twitter at Nuclearcast. Listen, follow, and review the show on Spotify, Apple Podcasts, Amazon Music, or wherever you listen to your favorite podcasts.